Thanks for tuning in at Brackeys.
Hello everyone and welcome to the second video on creating a tower defense game in Unity. Today we are actually going to be making an enemy and making him move around the scene. The graphics for this enemy is going to be very simple, at least for now, but we are going to program waypoint behavior and enemy movement, so that's going to be very fun. So let's dig right into today's video. So you can see that I'm here in Unity, and this is where we left off with creating a start and ending point. And there are lots of different ways to do enemy AI. In our case, it's very simple. We want to move from point A to point B along a pre-specified path. And when doing it this way, the easiest way is really to set up a set of waypoints, in our case just empty game objects, that the enemies will use to guide them along the path. So they will move towards one waypoint, find the next one and move towards that. And it will do that until it reaches the end. And then in our game we want that to destroy the enemy and we want to lose some health. So how can we really set this up? Well, I think before we go ahead and do anything, we should just move our camera into some kind of some position that makes a little more sense than this, and then maybe create some kind of ground plane, just so we have a game that makes a lot more sense to look at. So if we go ahead and take our camera here, find our main camera, and at the moment it's moved back a bit. Let's start by moving this up a lot, and then rotating it a bit. Let's move it over here actually. So moving it over like this, moving it back, and then moving it up some more, then rotating it on the, I think that's the X, we need to rotate it, and we need to rotate it about maybe 45 degrees, maybe even more, something like 60 degrees, and then move it up even further so that we have a clear overview of what's going on with our map. And you can of course adjust your camera's position to change. It's going to depend on the map that you've created, and I actually want this to be even more at an angle. I want it to be almost entirely viewed from above. So right now this is going to be that's a bit too much, so let's do 65, and let's bring it back a bit, bring it down a bit. Something like this is going to work just fine for now at least, and we can always change stuff like this later. We might also add the possibility for the player to move the camera around on his own. So without further ado, what we want to do here is create some kind of ground plane. So let's right click, go to 3D object, and then select cube. Let's reset this and call this the ground plane, not to be mistaken with our path object, which we just called our ground. And what we can do with this is move it into the environment and have it sit at the top here so we can easily find it. And we want to take the scale here and bump that up to something crazy like 1000 by 1 by 1000, something like this, and then take some kind of very matte material. So let's create a new material and call this the ground plane and drag that on there. And then we can go in and change the albedo here to something very dark, something like that. Bump the smoothness all the way down and then the metallicness up a bit. Something like this looks pretty nice. And then what we need to do is of course move this ground plane down. So if we find our ground plane here and then move it down by using control, we should be able to get our platforms to just stand on top of this plane. And what this does, instead of just changing the skybox to a solid color, is it gives us a bit of shadowing from our platforms onto the ground, and I think that's going to look very sweet at a later state. If you don't want this, you could of course just go into the main camera, change from skybox to solid color, and then choose a color similar to this one. And what I want to do is I want to change the material of the ground plane to something a bit bluish, just to give it a kind of a tint so that the game looks a tiny bit more interesting just from the background color, so it's not just a boring gray. So this is a bit better, and of course we will be adding more graphics to the game as we proceed. So this is fine. It gives us an overview of our map for sure. So now we can go ahead and collapse that environment there, and we can go ahead and create an enemy. So if we right click here and go on the 3D object and then select sphere, reset the transform and call this our enemy, and then we can drag this guy up and over and put him somewhere along our path. Let's do that. So let's move him up here and move him over and put him near our path, just so we can see what it will look like when he's walking down it. And he's going to float about at this height, and I think that looks fine. And then what we can do maybe is just move him over and then scale him up a bit. So let's do at least a scale of 2 by 2 by 2. I think that just made him a bit easier to see. And let's go ahead and create a material that stands out a bit from the rest here. So let's create a new material and call this the enemy material and drag that onto our enemy. Again, changing the albedo and the smoothness all the way down on this one. The albedo to some kind of light blue, almost cyan color. And I think something like this actually looks pretty great. We want it to be very bright and pretty saturated. So I think that looks pretty nice. And you will notice right now that the light is coming from the same angle as our camera is. So if that's something you want to change, you can of course rotate around the light here until it looks more like something that you would like. So I would like it not to come from the right here, but maybe from the left, something like this. And you can even play around with the intensity of the light so that it will suit you better. Right now it's currently tinted, and we can maybe go ahead and untint that at least just a bit, something like that. Okay, so that was basically our scene setup for now. So we can take this enemy here and we can turn him into a prefab by simply dragging him down into the project panel. And we can now save our scene. And now it's time to create some waypoints for our enemy to walk along. So in order to do this, let's right click, go under create empty, and let's reset the transform on this and call this one a waypoint. And for this, we are going to just move it over here and move it up so it will be right around the path here. And what we will do with this is we will add a icon up here. So click this button right here and you can select an icon. And I'm going to select this ruby shape here, which I kind of like. And I'm going to scale up the 3D icons here quite a bit so it's easy to see in the game. And this is of course not visible in the game itself, but only in our scene view. And the enemies are going to be walking about here. So that's going to be fine. And we don't need to specify a waypoint right at the beginning because this is where we will spawn them in. And then they will seek towards the first waypoint. So our first waypoint will be over here. But again, because we're going to be creating many waypoints, let's make an empty game object called waypoints and make sure that this is at position 0, 0, 0. And then we can take our waypoint, make a prefab out of it and drag it under the waypoints. Let's also make a folder in the project panel, one called not waypoints, but prefabs. And we can take our enemy, our node and our waypoint and drag them under there. And one called materials, and take our many materials and drag them under there. By the way, if you want to get the same old project setup that I have here, the old project viewer instead of the large icons, what you can do is simply go up here and select one column layout instead of the 2 column layout. I just find this a bit easier because it doesn't take up as much space, but it's completely a preference. So now we can take this waypoint here and move him over to that location right there, I believe. Is that correct? Let's see, is he in the center? It looks like it. And then we can duplicate him and move him down. Something like there. Duplicate, move over. And we're just going to keep doing this. Every time there is a corner, we're going to move it over until it fits. There, move it down to there. And if you want this to be easier to see, what you can do is you can press on the Y here to view it from above, and then you can press on the center of this up here to turn it into isometric view. And that makes it a bit easier because there's no longer perspective involved which makes it easier to line up these arrows. So if I select the other ones, you can see that's right in the center, that's right in the center, that's perfect. So let's duplicate this one, move it down here, make sure this arrow is right in the center. And I'm just going to keep doing this until I've filled up the entire board. And finally, we are going to also place a waypoint at the end point. And that's because we might spawn at the start point, but the enemies won't know to go to the end point unless we actually place a waypoint there or add some kind of reference to that place. So this is now our map layout, and we can go ahead and collapse the waypoints here. So what I want to do is basically add a script that has a static reference to all of these different waypoints so that we can very easily reference them through an enemy script. So if we go on our waypoints here and add a script, and this is going to be called waypoints, how creative I am, and let's double click this to open it up in Visual Studio. And if what I explained doesn't make sense to you, it hopefully will in a second, or you can of course just write after me and maybe you will get it when we actually implement this in the enemy script. So you can see that I'm here in Visual Studio, and I'm going to delete this namespace because we are not going to be using it, and I'm going to delete both the start and the update method for now. And what I want here is basically a public static, and we want to make this static so that we don't need a reference to the script. We can just access this field from anywhere whatsoever. So a public static, and then this is going to be a transform array, and an array is basically just a list of items, and we use transform whenever we want a list of game objects in our scene. So that's perfect, and we can call this one maybe points or waypoints, whatever you want to call it. And then we're going to recreate the start method here, and then inside of this start, actually let's do this in awake. There we go. And inside of the awake function, we basically want to find all of the different objects that are a child of this object that is parented to this waypoints object. And then we want to load them into our points array. So in order to do this, we set points equal to a new transform array. And the length of this is going to be our transform dot child count, and that's the number of children that is currently on the waypoints, and that is in our case going to be it starts at 0, so that's in our case going to be 13. Cool. So we are going to make an array of 13 points, and then we are going to say for, and then we are going to do int I as long as I is less than, and then points dot length. We are going to say transform dot get child with the index of I. So here we are iterating through every child of the waypoints object, and then we are setting, or we are pushing that into our array at the ith slot. So basically we're saying there are 13 children on this object, create 13 spaces in the array, then loop through them so that I is equal to 0, 1, 2, 3 on all the way up to 12, and then set points I, that means the 0th place, then the 1st place, then the 2nd place, and so on in the array equal to that child. So now we have a list of all of the children that is static and then we can easily access. So what we can do now, and why this is smart, is because when we then spawn in an enemy, it doesn't need to be aware of any waypoints. It doesn't need to find them or order them. We've already done that. What we can then do is simply have our enemy prefab here, and I'm just going to drag this into the scene, and I'm going to have it start at the start position here just for now. Later what we can do is we can add some kind of wave spawner that will take care of spawning these in, but I'm going to add it there, and then I'm going to add a script that we call enemy, and this is in charge of moving the enemy from one place to another. And actually we might even want to call this the enemy movement, and maybe split that up in some way, because we're also going to have health and stuff like that. No, let's just keep it in one script because I don't think it's going to be that large. But if you are planning on adding a lot of functionality, you could definitely split this up. But for now, we'll keep it in here. We might split it up at a later point. So what we will do is first off add some kind of speed variable, and that is going to be a public float so that we can have decimal places. And we are going to set that equal to maybe 10 at the moment. That number is of course completely arbitrary. You can adjust it inside of the editor. Then what we want to do is we want to have some kind of target. And I'm going to make this private because we are only going to be setting this inside of our enemy script. So we're going to have a private, and our target is going to be a transform target, and also have a private integer, which is the waypoint index. And that is going to be defaulted to 0. And this is going to be the current waypoint index we are pursuing. So first the 0th, then the first, then the second, all the way up to 12. Okay? And then inside of our start method, we are going to set target equal to, and then we are going to use this waypoints.points array that we just created. So now we are referencing the points array inside of the waypoint script by simply doing this because it's static. And then we want the first one, which is of course the 0th, index of 0. And now we are pursuing that target with the waypoint index of 0. So that's perfect. And then what we want to do is we want to every frame that is called, so inside of the update method, we want to move a little closer to that target. And the way we do this is we get some kind of direction in which we have to move in order to get there. So this is basically the direction we have to point in order to get to the waypoint. So we get a vector, which is 3 numbers that represent the X and the Y and the Z movement that we need to do in order to point towards the target. So in order to do this, we make a vector3 direction and set that equal to, and the way you get a direction vector from one point to another point is that you simply subtract them. So this, in our case, we want to point from our current position to towards the target position. So that's going to be target.position minus transform.position, and this is going to give us a direction vector. What we can then do is move with this direction vector. So we do that using transform.translate, and translate basically means moves the transform in the direction and distance of translation, and the translation is given by, guess what, a vector. So our vector here is going to be our direction, but we also want a speed to move. So I'm going to normalize this. So I'm going to use direction.normalized to make sure that this is always going to have the same length, the same fixed speed, so that the only thing controlling our speed will be our speed. So if you don't know about vector maths, this is just something that you know that you have to do. And then you can go ahead and watch some of my other videos, maybe explaining more about what this means. So let's multiply this with our speed in order to get the actual speed that we want to move at. And let's also multiply this with time.delta time. And time.delta time is something we multiply with that will make sure that the speed that we move at is not dependent on the frame rate, because it's not all computers who run the game at the same frame rate, and one computer might even vary depending on what is happening in the background or whatever, how much stuff is on the screen. And therefore, if we moved every frame with the same amount, no matter how many frames were drawn, then we would suddenly move very fast or very slow. So to solve this issue, we have the time.delta time, which is the time passed since the last frame. So if a lot of time passes, meaning not a lot of frames are drawn, we move more each frame than if a lot of frames are drawn and not so much time passes. Okay, so that's what we're doing here. And then we want to simply say that the space that we want to move relative to is the world space. And now we are done with this part of the code. So the last thing that we kind of need to implement is some sort of way for us to switch waypoints. But I think that before we actually do that, we want to jump back into the game and maybe just try this out. So I'm going to switch back into perspective mode here, and let's see that this waypoint index is assigned, but its value is never used. That's because we haven't implemented this yet. So let's try and hit play and see if this works. So you can see that our ball starts moving towards the waypoint and then it stops. And that's because we don't have any waypoint switching, but everything is actually happening as we want it to. So let's switch right back here. And then we say if we have reached the waypoint, that means that we are within a very small distance to the waypoint. In an ideal world, we would be exactly at the waypoint's position, but because this is a computer and it might sometimes do some smaller mathematical uncertainties, we are going to say that if we are within maybe 0.2 units of the waypoint. So if our distance from our current position to the waypoint is less than 0.2, we've reached the waypoint. So that's what we're going to say here, and we're going to check for the distance by using vector3.distance, and then we give it the first point, which is our position, so transform.position, and the second one, which is the target.position. If that is less than or equal to 0.2 units, well, then we've reached our waypoint, and then we want to get next waypoint like this, and then we can make that method down here, get next waypoint, and we simply do this by saying that we want our waypoint index to increase by 1, so that we just say ++, and then we want our target to be equal to waypoints.points to the waypoint index. So the first time that this code runs through, it's going to set the target equal to the first waypoint. It's going to move towards it until it reaches the waypoint. Then it's going to get the next waypoint. It's going to say that the next waypoint we are going to get is this one plus 1. So the second time this is going to say 1, and the third time it's going to say 2, and so on. And then it's gonna get the waypoint at that index and set it as the target. And then it's going to go back, move, distance check, and when that passes, it's going to do it again. And so keep on going until there are no more waypoints. And let's just set that in. So we can just say that if waypoint index is equal to or is larger than or equal to, I should say, the waypoints dot points dot length, so the total amount of waypoints -1, I believe, yeah. Well, then we want to destroy this object. So we want to destroy our game object here. Our enemy is dead. So let's try and do this, and just to speed things up, I'm going to increase the speed of our enemy so we can see whether or not it works when he gets to the end here. So already there's an error, and that was an example of when I need to loosen the requirements here. So let's do 0.4, and that's going to depend on your speed here. But I'm just going to say 0.4 now. That's going to work just fine. And you can see that a little guy races through, and when he gets to the end, oh, it's going to say index out of range. So it seems that the reason this wasn't working is that the destroy operation sometimes take a bit of time before it cleans up the entire object. And that means that the code might run further down here before the object is destroyed. And in that case, we will of course get an error. So what we want to do is simply hit return on this so that we are sure that it won't go down here before the object is destroyed. So that should fix everything. And we hit play now. And I'm even going to show you something really cool about this. If we add a lot of enemies in here, so I'm just going to add a bunch of enemies. Here we go, just 1, 2, 3. and I'm just going to distance these just a bit. It doesn't matter where they start, they will seek the first point whenever that is. You can see that it works with multiple enemies. And for some reason now it's not doing anything at all. That's because I forgot to add the enemy script and apply that as a prefab. Now it's working. So if we add these 3 enemies, we can see that they are indeed going down the path. And then if I select one of them and change the speed, it does this at runtime. So I can change the speed of these individually and have them go through the path. And you can see that when they reach their end destination, they are indeed destroyed. So that is the pathfinding system that we are going to be using. That is the very basis of our enemies. And I hope that you've enjoyed this tutorial as much as I have. Without further ado, thanks for watching, and I'll see you in the next video. Thanks to all of the awesome Patreon supporters who have donated so far, and a special thanks to Lux Game TV with the real name Jeff Sacred.